Hello again. Welcome back to the Advanced Math Series. I'm Mr. Hunt. Today we're going to be covering Lesson 8, where we're going to be going over 3 sections. It's pretty quick. 8A, Statements of Similarity. 8B, Proportional Segments. And 8C, Angle Bisectors and Side Ratios. Alright, you guys know I'm still out this week trying to get these videos up. Did you guys like the OneNote versus the whiteboard? Please let me know. And don't forget to request help to the group chat if you need any. This lesson is going to go fast. Thank you. Alright, jumping right into Lesson 8. 8A, Statements of Similarity. You can go ahead and read over what the book has for you. And then we're going to go jump into example 8.1. It shows in triangle ABC, segment BD is the altitude to the hypotenuse AC, showing the following. AD over AB is equal to AB over AC. Solution to this is when you're asked to show that the two ratios are equal, we look for similar triangles, and this one has two right triangles. We can see it automatically with the right triangles here. It'll be triangle ABD and triangle ABC. And then you're going to write the ratios by putting ABD on top. Alright, so ultimately, I want to get a different color out here. Let's go with white so you can see it pretty well. Let's see. You're going to write the ratios. Put the ABD on top. It's going to be AD over AB. Then we'll have DB over BC, and then AB over AC. So what we did was basically we had these two. They correspond with these. And then DB corresponds with AB. Oh, I'm sorry, BC. I have an eraser for that. Right, and then we had AB correlates to AC. Alright, these are all equal, right? And they wanted to, which one do they want us to do? AD over AB. So they want us to do these outside terms here. Proven. AD over AB equal to AB over AC. And that's the solution right there. They asked you to do something very simple. Alright, moving on over to 8B, proportional segments. This will not be easier. It's got a whole lot of math for no reason, really. It wants you to show you to prove two parallel lines cut proportional segments from any two intersecting transversals. If you remember what that looks like, you're going to have two parallel lines. Yay. And we have two intersecting parallel lines. And they want us to prove that that and that are proportional segments. And that's what we're going to do. So you have A plus B is over A is equal to C plus D over C. This means that B over A is equal to D over C, where A and C are not equal to 0. Right? I'm not going to have 0 in the divisors. In order to get this down to what this is, B over A equals D over C, you just factor it out. You have A plus B over A is equal to A over A plus B over A. Ultimately, those are going to go away, become 1s. Subtract 1s from both sides. And you'll end up with your B over A is equal to D over C, which is what you're looking for. Easy? Alright, that's the proof of it. Now we have example 8.2 where they tell you to find X. X is... there's your parallel lines. You got a couple of them. They're cutting here and there. And you just simply set this up in the equation. X plus 1 over 13 will be equal to, proportionally, x plus 4 over 19. It will happen this way because of the proof we just did. Right, you factor all that out, you'll end up with 19x plus 19 is equal to 13x plus 52. Do the arithmetic, you'll have 6x equals 33, and x is going to be equal to 11 over 2. Pretty simple solution. And that's basic for proportional segments in 8b. Last but not least, told you this is going to be fast. Lesson 8c, we're going to do angle bisectors and side ratios. This one's probably easier than the last one. Basically, line segments which bisect an angle of a triangle, it's going to divide the opposite sides into segments proportional to the other two sides. So if you have an angle bisector, let me get out my handy dandy laser pointer. Angle bisector here, it's going to cut these into proportional segments with these guys. Show you that right here. You can say that A is to B as C is to D. But the other way is true as well. A is to C as B is to D. This works with bisectors. These have to be equal angles. You're cutting it in half. It comes out. And you've cut these into proportional segments with these guys. Okay? So this one right here would be A over B is equal to C over D. This one is A over C is equal to B over D. Either way, you're going to have the same exact answer. Let's go ahead and do this one real quick. What color are we feeling? Let's go with some blue. All right, in the triangle ABC, segment BD is the angle bisector of B. So we found out this is their angle bisector, which makes all these numbers here proportional. We want you to find x. 10 over x is equal to 15 over 12. Cross multiply, we'll have 15x equal to 120. 15 divided out, x equals 8. Not too hard. Same story here in example 8.4. In triangle ABC, segment AD is the angle bisector. All right, we've got this angle bisector. We've got all these. We have one variable missing. How do y'all want to set it up? You want to go here to here? Really doesn't matter. So x over 20 is equal to 6 over 14. We'll end up with 14 x's, right? And that will be equal to 120. 14, 14, those are gone. X is now equal to 7, 6, all right, 60 over 7 prime. We're done. X is 60/7.